So today we are going to see the basics of MATLAB, which is required for facts. So as I already told you, tomorrow you will have fact session where SVC, UPFC, StatCom and all those things will be discussed directly in MATLAB. And after that you have OpenRT. Okay, they will be connecting you from Bangalore. So they will also handle these MATLABs with their hardware, that is OpenRT. So for that session, you require some basic knowledge of MATLAB. So many new participants here and many other centers have also been connected. So that's why we are just doing the basics of MATLAB. So like many of you would have like used MATLAB, but for the newcomers, from where to learn MATLAB? As in my before lectures also I have told, the MATLAB demo is the best place where you can go search for materials and learn MATLAB. So you can go to the MATLAB demo. In MATLAB demo, you have lot of modules available, where for each toolbox also you have lot of modules. I'll be just showing you. Apart from that, you can even go to the MATLAB file exchange. So once again, I'll just show you the MATLAB file exchange. So you can just go to Google. Okay, so here I have just written MATLAB file exchange in Google. Just type this MATLAB file exchange. You will get a file exchange MATLAB center. Okay, apart from demos, in demos also you get a lot of material, but apart from that, here research oriented material. Those who want to get some research oriented material, you can go to this website, MATLAB file exchange. And here in the MATLAB file exchange, if you go, you have examples for function apps, you have examples, Simulink models, all these things. You can go to the Simulink model. So in Simulink model, you get all the facts devices. So just you have in some number of other things also for BLDC motors or like machines, power electronics, and you have for power system also many applications. It is already robotics and all these things are available. Even examples with hardware when you want to connect. So here we are DGs or facts application is our aim. So you can go for facts. Okay, so when you put facts, automatically number of examples of say UPQC, UPFC, DStatCom for power quality enhancement, DStatCom closed boost converters. So I don't say that these are not available in the demos. Demos also it is available to some extent, but here you will get more applications like real time. Those who are doing PhDs and MTech, for them this will be a very useful thing. So don't copy as such. Take this material and you have to modify it and use it in your work. So one more thing you have to remember, when you're downloading this, sometimes it will not run fully. Okay, so that you have to modify it. So one of the mistake, like problem what you may face is, some of the systems will be masked. So I'll be telling you the concept of mask. So in that, you have to set some of the variables. Once you set the variables, automatically your program will run. The other problem is when you download it, your version may be different. So you're downloading a version of 13, but your system is in 16. Or might be you're downloading a version 10. Somebody has put a thing version 10. So in that case also, when you see the error, you will understand that is, say they would have given this mux is not compatible. So just remove that mux and put another mux. Okay, sometimes the scope will not be compatible. In some cases, the power electronics devices like thyristor will not be compatible. So this problem will exist when you sometimes the same version, there will be no problem, but many of the times the version will be different and you will face this problem. So the main thing what you have to do in this case is, you have to just see what is the error and correct it and use it, and don't use it as such. You have to, like according to your application, you have to modify and use it. So here, say for example, I am seeing this UPFC. I just want this fax device UPFC. So just click on this. So you will get all the detail about this UPFC here. Everything is written and the author's name also will be there. You can contact them for further. Say download zip file. So you just go and click on this. The zip file will open. Okay, so here it is asking for the save option. Just click OK and open. So automatically this zip file will come. So what you have to do, you can just go and directly double click on this and open it and run the program. But sometimes, as I told you, it may not run. So in that case, what you have to do, you have to like see what is the error and you have to modify it. But all the models are working models only. You have to make it according to your application. You have to change it. So this one thing you can remember. This is a very useful site for those who are doing research. Okay, and when you try to download first time, say now I entered my user ID and password. Those who are entering for the first time, it will ask you for the user ID and password of MATLAB. So if you go and create a login. Okay, once you create the login, a mail will come to your mail ID, and that mail ID, once you go and click OK, there is a link will be given. You click on that link, they will activate your account, and then you have to come give the user ID and password here. Then only it will download. So many of the participants, many times they've asked, when they download, they will not be able to download some of the things. It is not like that. You have to create your user ID and password, then only it can be created. So now we are leaving this. Let us go to our thing. We will just work on MATLAB. Okay, so MATLAB, so here 2015 I'm using. MATLAB 2015. So the latest version is 2016B is the latest version of MATLAB, 2016B. And now in March, the 2017A will also come. Okay, so every March and September they release the new version. So until now, the latest version is MATLAB 2016B. And once you open the MATLAB window, mainly there are two types of programming you can do. One is by coding, directly doing the coding, and second one is through Simulink. Okay, so two types are there. You can use both. Say if you want to write the code and do it, that is also possible. You can write the code. Or Simulink for fax and DG applications. Fax, all the power system things like the transmission lines, the IEEE buses, or you have the fax devices. So those things, when it want to be when you want to simulate it, the main problem what you face is those devices are required. So that advantage here is all those things are already available in the Simulink library here. All these fax devices are available in this, where you can directly go and take it. Okay, so that is a thing. That is a thing. Or if you want to write coding, you can just do it. But it is there also. Like say I told you the MATLAB file exchange. There, if you go to the coding session and search for fax devices, some of the codings also you will get it. That also you can use it. But the simple thing is graphical user interface. Like you can just go for the Simulink. Simulation is very simple in Simulink. So in order to go into Simulink, you can go directly click on the Simulink library, or you can write Simulink here. There are two options. So one more option is there. You go to new, and there also one option is there. So you have to just wait because it takes little time to open. So don't double click many places. Don't open many things. We have to just wait for the window. So three ways you can open. One is Simulink library. You can click it, or in the command prompt you can write. This is the command prompt where you can write Simulink. Or the third option is go to this new. There you have a Simulink Simulink model available from where you can open. So now you saw the Simulink library is open. You can see the Simulink library which is already open, and you can just go to this new Simulink model. Okay, the Simulink model will open. Okay, what I did, I opened the library, and here there was an icon. I can just click it once again and show you. Here you can see you can see here an option once again. So here you can see an option. So this is the Simulink model builder. When you click on this icon, a model will open. So let me just open this. So this is the model open. So now it is very simple. Whichever elements you want, you have to just say I'm using the commonly used block. So in case in commonly used block, I want the subsystem, or I want this input output port, or the mux, just drag and put it into it. So you will get the blocks here. Okay, so and you have to just connect everything. So mostly the blocks sync and sources we'll be using. So sync is this one where you these are the different sync blocks. You have scope, which will be commonly used by us. Like scope is a place where you see the output. Okay, similarly source is there. Source is also say pulse generator. That is also a common thing you use, step input, signal generators, and all these things. In signal generator, so for example, you want to give an input to the irradiation, as in a PV system. Okay, the irradiation or temperature. There, what you can do, you can use a signal generator and you can make a pattern there. For example, say signal generator I have taken. If I double click it, you can just make radians per second, the units you can give, and you can set the signals there. So signal generator is also there. Signal builder, sorry, the actual block which I wanted was a signal builder. So in this signal builder, if you double click, automatically the waveforms will come. So you can see here. So if you want to give an irradiation for 6 seconds of 1000 watts per meter, you can just go and change it here. You can change the values and make it 1000 watts per meter squared. And this will be the signal that will be going inside the required block. So you can just, these are some of the blocks available. Similarly, if you go down, you can see number of blocks like fuzzy logic. For neural network, you have block sets. Similarly, you have Simscape. Simscape also, there are a number of things like those who are from mechanical, they use Sim mechanical, Sim hydraulics you want, you can just go and use Sim hydraulics. Those are from electronics background, they use Sim electronics where you have all the sensors, accelerometer, gyrometer, and all those things are there. Semiconductor devices are there, P-channel, JFET, N-channel, MOSFET, and all those things. Passive devices, switches are also there. Then you have additional components like many PSpice components are there. Even in hydraulics, if you see, you have a number of mechanical oriented things. In Sim electronics, even you have something called the PV module. That is also available, I think, yeah, here solar cell. So those who are working in distributed generation, when you want to make a solar cell, you can use this solar cell. Number of solar cells, how many cells are there, you can make your own solar panel also. But when all these solar panel characteristics and solar panels are already available in MATLAB file exchange, so that's what I said, you need not go and again create it. Now in the latest version of 2016, these solar panels are already available. In older version, wind power and wind power modules are already DFIG and all those things are present. But now if you see the latest thing, solar panels and solar modules and all the there's a common solar module available that is in demos. They have not put it here, but solar module, if you take it from demo and put it here, there you can go and change all the characteristics, the open circuit voltage, the short circuit current, and everything can be changed. That is in 2016 module, it is already available. Okay, so these are the things. And similarly, those who are from electrical background, you have something called the Sim power system. Okay, Simscape components are there, specialized technologies are also there. So there is some error in this. Simscape components. So in Simscape components also you have sources, sensors, semiconductors, switches, the fundamental components are available. So you can see the like all these components you will be using in our works. The rectifiers are there. You can just see all these three-level converters, 6-pulse gate multiplexer. So all these things and all these diodes, the MOSFETs, and all these elements are already present in the Simscape. Okay, so these are the things available. And now like many of you have used MATLAB, but those who don't know these basics of Simulink, I'll be telling you, as I already told you, we'll be using it. So we will see some small concepts. We'll see some concepts like how to make a subsystem, how to mask a subsystem, and how to use go-to blocks, how to use coding in Simulink. So these are some of the simple things which we are going to see today. For this, we are just taking an example, a power electronics example itself. We will just take an rectifier. So all of you know a rectifier. So let me take a rectifier and start. So this window, let me draw a rectifier, and then we will just simulate the same thing in MATLAB. So for rectifier, I am just taking, say, 4 diodes. All of you know about diode. So I am using a bridge rectifier. So the same thing we will be simulating it. So this bridge rectifier. So this is a full bridge rectifier. And this, in the place of diode, you can even use a thyristor so that the firing angle can be changed. So let me convert this into a thyristor. Okay, so here I can connect an AC source. This is an AC. Okay, and the load is connected here. So I'm just connecting a small load here, maybe an R load, an RL load. Okay, so here let us have a load also. So this is the thing, and we will name this thyristor will be your T1, this will be your T3 or T2, anyway you can just name it. This is your T3 and this is your T4. Okay, so input what you are giving here is, as I already told you, it is an AC supply. So let us, first of all, we want an AC supply, like, because that is the input what we give. So let us draw here an AC. Okay, so we have drawn here a AC supply. So in this AC supply, when it is a diode, what happens? It is full bridge rectifier. So first say if this is a diode, all these are diodes, so D1 and D4 are conducting. So in that case, you can see here you will get the full output here. Is it? Similarly, when T2 and T3 are conducting, in the sense D2 and D3 are conducting, you get the output. Full bridge. This is full bridge output. You get it like this. But if it is a thyristor, there is an option that you can change the firing angle, is it? Once you fire the thyristor, then only they will get turned on. So let me just imagine that I am just giving a firing angle at some 45 degrees. I am just going to fire T1 and T4 at 45 degrees. So let me keep one cycle here. It is 50 hertz. Indian we will take. So it is 50 hertz. So 50 hertz is nothing but one cycle, that is 360 degrees. This is 50 hertz. Okay, so now the thing is we want to fire at 45 degrees. So like all the computer or the controllers, they will not understand what is degrees. We have to tell it in terms of time. Okay, so here if it is 360 degrees, it is say 50 hertz, it is 360 degrees, it is 20 milliseconds. Okay, 1 by 50 is 20 milliseconds. So for one cycle, it is 20 milliseconds. So now it is, we want to fire at 45 degrees, it is 2.5 milliseconds. Is it? 180 degrees is nothing but, 180 degrees is 10 milliseconds. If the whole thing is 20, this is 10 milliseconds. So 90 degrees is 5 milliseconds. So 45 degrees is 2.5 milliseconds. So at 2.5 milliseconds, I have to fire my T1 and T4. So let me give a firing pulse here. So this is say 45 degrees. And after this, so at 45 degrees, what will happen? My thyristor got fired. So I'll get the output here at this point. Till then, I'll not get any output. Once I fire, I will get the output from this point. It will follow the same AC supply. After that, this is for the firing for T1 and T4. And so I'll just tell you about the, I'll draw the circuit directly and show you. Okay, till now you know the circuit. So I'm just drawing the thing. Phase shift, I'll just tell you. So here there was a AC supply. Okay, so here we were first seeing for 45 degrees. So 45 degrees, the first thyristor T1 and T4 was fired, and it has to be fired repeated. This firing pulse has to be repeated after 20 milliseconds. Okay, so here say what will happen is this one here you will get a waveform. Okay, and similarly this waveform will repeat after 20. This is positive half cycle, because during positive half cycle only your T1 and T4 are turned on. This is the firing pulse for T1 and T4. So you have to just remember that here if you're firing 45 degrees, after this 20 milliseconds, again 45 degrees, you will be firing at this instant. Okay, so similarly the next firing is at for the negative cycle. So when you will be firing it, when you want 45 degrees, so 180 degrees plus 45. Okay, so that is in terms of time. If you say it is 10 milliseconds plus 2.5, that is 12.5 milliseconds you will be firing this, and when you will repeat this again after 20 milliseconds. Okay, if you want. So what will happen for this case also, here the thyristor will be fired like this, and here also again you will get the firing. So this is half bridge rectifier, pulsating half bridge. In this case here you are firing your T3 and T2, and it has to be repeated after every 20 milliseconds. So here if you see, this is yeah, diode in the sense, in the case of diode, what will happen is, when you're using diode, you will get a full waveform like this. Okay, from here it will start like this. This is a green one is in case of a diode. Complete thing you get. When you use a thyristor, that so much person you're firing here, at the point you fire, the output will come. So during the positive half cycle, your T1 and T4 are on. During the negative half cycle, T3 and T2 are forward bias. So only those thyristors you turn on. And the other thing is here, if you see, this gap is 20 milliseconds. This gap is 20 milliseconds here. Every 20 milliseconds you have to repeat it. And here the gap is 2 milliseconds, 2.5 milliseconds. This one, the first gap is 2.5 milliseconds, and this gap is 12.5 milliseconds. So here it is 12.5 millisecond is the case in this case. Okay, so this is how we will just define it. So the same thing, let us draw in the MATLAB environment and just see what is happening. Okay, so I'm just going to the MATLAB environment. So for this case, we want the library as well as this. So we want our library also, we can close. It is not required because in the later version you have an option for getting the thing, like you can have the search here itself and in the window itself, and you can get it. So now I want a thyristor, I can give THY. So automatically all the thyristors and all these things which starting with thyristor will come here. So you need not go to the library also. If you know the name, you can just search it here. So I just want a power library, like power electronics. From power electronics, I have detail model and thyristor model. So detail model is, if you know all the full details, this number circuit about all the parameters, if you know, you can go for the detail. Otherwise, you can take the thyristor model. Just click on this and enter. Okay, just click on the element and enter. Automatically, so it is asking for T resistance, that you can go inside and also do it. So I'm just enlarging it and I'm doing Control R to rotate it. So I just want to rotate so that my gate is down. So Control R, if you put, it will get rotated. So let me just zoom. So I think little more clear it will be. And I want 4 such thyristors, is it? So I have taken thyristors. So in order to take 4 such thyristors, copying Control, press Control and drag it. These elements it will copy, or Control C, Control V also you can do. Okay, so I want 4, I have done it. Then this cathode and cathode, I'll be connecting it together. Anode and cathode. This anode and cathode. And here anode and anode. Okay, so this I have connected together. Now I require an AC supply, so AC voltage source, so AC. So here, when you connect, to click AC itself, that is coming. So you can see here. So AC is when you click or directly it will come. So you just go and choose the AC voltage source from the power library. So just click on it and click, automatically that window will come. Okay, and you can give the amplitude and all those parameters. So next load, so RLC load I want. So I'm just taking an RLC branch. So you can even take RLC load if you know the real reactive power and all. Here in case if it is a branch, you can just give the resistance and inductance capacitance value. If you know the real reactive power, you can take the load also, if you know the correct thing. And here I'm just rotating it. Okay. And here in case if you want only RL load, you can just go double click on this here, RLC, all the options, R you want, only L you want, C, RL. So all those options you have it here. Now you can go and give, say I'm giving some 40 ohms and some 80 millihenry. Okay, according to the problem, I'm just choosing it. Okay, apply and okay. So here you have a measurement port also. So you can here if you want the branch voltage and current, branch current. In case if you want to have a multimeter and measure all these things, you can just click on this. So what will happen? The branch voltage and current is coming for measurement. So now if you put a multimeter outside, that will give you the branch voltage and current at any instant. Okay, so apply. Okay, so this is how you have just put a resistance like a load here. Now what we require is, no, this is the scope where you see the output. Okay, the output. I want around 5 outputs. I want to watch around 5 outputs. So just double click on this parameter. And here, if you go to this parameters and click on this, you have a window here. And here you can go and give you how many axes you want. Say I want 5 axes. I can just give 5. And you have something called decimation. So this decimation is very helpful. Say here in decimation is 1. It will take every sample. How many if the sample, like say for every second you're taking some 10 samples, so all the samples will be taken in this case if the decimation is 1. Okay, so that sample rate also, at what rate you want to sample, you can just, I'll put a power GUI and show you. There you have a discrete option, and there if you make it discrete, you can just go and choose how many samples do you want per second. Okay, how many samples, at what rate you want to sample the system. So that is all possible there. So here decimation, if you give, what will happen, say if you want to take from 10 samples, you want to take only 1 sample, then you can give here 10. So in that case, it will take only 1 sample from the 10 samples. If you give 100, from 100 samples it will take. So it depends on your application. Because if you take more number of samples, what will happen, you will get a very pure correct waveform. But the thing is, memory will get occupied. There will be less memory space. Okay, many times this problem will come. Those who are doing research, the memory will be occupied. So in such cases, say for example, it's a solar application, and you want to take the data throughout the day, or from 9 to some 6 o'clock, you want to take the data, and you have connected your real-time system online. So in that case, every second, say you take every second you're taking data, what will happen? Your memory will get out. So in such cases, what you can do is, you can just give after an hour. In the sense, say for 1 hour, it is around some 10,000 samples you're getting. So in 10,000 sample, only 1 sample you want. In such cases, what you can do is, you can just put this decimation. Okay. And history is also there. That limit the points to last 50,000. So if you don't want from initial point all the points you want, you can unhide it. Save data to workspace, there is an option. That also you can just click on save data to workspace. So what will happen? The data which comes in the workspace, in the scope, will go into the workspace also. There, here if you click on this option in Power GUI, 1 block Power GUI I'll be putting in future. That is very important. I'll be telling you the reason also. In Power GUI, you have number of options like FFT analysis, load flow analysis, and all those things. So if you save this data to workspace, then only those blocks will operate. Okay. So you just remember this. You have to click on the save data to workspace, click apply, and click OK. Okay. So say here 5 I gave 5. I call like 5 windows have come. So this is my model. So here you can see there are 5 inputs. So if you want to measure the current and give it to it directly, you can't give. You require, as in labs when we do, we require a meter. Same way you require a current meter here. So current measurement, you can just give. So this is the ammeter, and this ammeter, as you all know, it has to be connected in series. So I'm just connecting it in series. Similarly, you require a voltage measurement. I'm just clicking this block, so you will get the voltage measurement. I'm just connecting this voltage measurement block also. So I want one more block of voltage measurement to see my supply voltage. Okay. So I'm just dragging this and putting it here so that I can just see what is my supply voltage also. Okay. Supply voltage also I have to set. So my supply voltage, let it be some 230 volts. So general voltage, what we follow in India, 230 and 50 hertz. It's not 60. In US it is 60, but here we can put it as 50, and other things are same. So apply. Okay. Here also measurement port, if you want, you can just click it on. So here, let us see the source voltage. So I'm just clicking. When the thing is dotted red line, it means that it is not connected. Okay, so here next we will see what is the output load voltage. Then we will see the current, load current. Okay, these are the things we are just measuring. Just drag it and put it here. Next, we want to see two more things we have put. That is the pulse generator output. We will just connect. Okay. So pulse generator we require. So two pulse generator we are going to take here in this case, because for T1, this we said that this is T1 and here it is T3 it's written, but T1 and this according to us this was T1 and this was T4. For these two thyristors we require one pulse generator. So let me give the thing as pulse. So pulse generator is here. I'm just clicking on it and I will just connect to it. Similarly, this one also will be connected here, pulse generator. Okay. So similar, next we require one more pulse generator. So this is the next pulse generator and this also can be connected to this. Okay, the two thyristors are connected to these two pulse generators. Okay, so the two pulse generator also connected. So as I already explained you, T1 and this was in our case it was T4. So these two are given to this pulse generator and these two are connected to this pulse generator. Okay, so we have given the gate pulse. Now we have to enter the value. So this value only I have already told you that one cycle is 20 milliseconds. So what was the period at which the signal should repeat? You remember? When this, say for T1 and T4 we gave a pulse and that should repeat I said. So how many seconds it has to repeat? No, that is for second thyristor, the delay was that. Every pulse, when should it repeat? After a cycle it was. So it was 20 milliseconds. Okay, so it has to repeat after 20 milliseconds. So I am giving it as 0.02. Okay, 1, 2, 3, 20 milliseconds. Okay, similarly, at what phase delay? At phase delay was 30 degrees, sorry, 45 degrees phase delay. So for 45 degrees, what was the angle? Sorry, that time? No, that is 12.5 is again 1.8, huh? 2.5. So first case we are giving it is 2.5, 0.0025. So that will be 1, 2, 3, 2.5 will be your first thing. So this is okay. First, this is for the first two thyristors, T1 and T4. Now we'll go to these two thyristors. For that we have to enter. So I just explained this. So similarly here, this pulse also should be repeating after every 20 milliseconds. Okay. But what was the phase delay, initial delay? That was 10 plus 2.5, 12.5. Okay, that was 12.5. So we'll put as 0.0125. Is it correct? 1, 2, 3. So it is 3, no? So 1, 2, 3. It is 12.5 milliseconds. So we are 12.5 milliseconds. We will repeat it. So that waveform also, if you want to see, you can just connect it. You can just connect and see. This is one thing. And the other option is okay, so this we have just connected. So now when you run, actually it has to run. And the other thing you can see here, measurement ports are here. So if you want, what you can do, you can connect a scope here and see what is the voltage and current across the thyristor. If you don't want those ports, you can just show measurement port hide. You can hide it. So in that case, that port will not come. Because now I'm going to do something called the subsystem. So when you do a subsystem, what will happen? These ports also, open ports will come in the subsystem. Okay, so it will be a confusing thing. One port anyway, one of the port I'll leave it open and the other ports just let me do it so you will understand what is that port. When it is left open, what will happen? Okay, so I'm just unclicking all these ports and only one port I've left so that you can see what will happen in that case. So now I think we are ready to run the program, but for this, as I already told you, something called power GUI has to be connected. So that is the power GUI. So this is the power GUI block. It is in continuous mode now. It is in the continuous. Okay. So you can even make it discrete. So when you will go for continuous and when you go for discrete is, say you have phasor models also. So you have discrete, you have phasor, continuous. So in phasor, mostly in power system applications, you go for phasor also. When you want to do the load flow analysis and like discrete when do you go when you want to connect a hardware? Okay, whenever you want to connect a hardware, the hardware are all discrete systems. This is a microcontroller. Microcontroller will take sample after every particular second. Okay, you're sampling it and taking it. Is not a continuous thing. You're not taking the value continuously there. You'll be sampling it and you will be taking it. The data which is coming from a microcontroller is a discrete signal. Continuous, let's say now when I'm running a simulation, I can keep it in continuous to see what is the actual, how does it actually look. Okay, so discrete also you can put it and give more number of samples, then you will get this continuous system itself. So that you can choose whichever if you want continuous, phasor or discrete, you can choose according to your application. Okay, so now we have connected, and here you can see these tools also available. You have FFT analysis, load flow analysis, steady state, initial measurement, and all these things available here. So in order to run this, so 20 milliseconds I have given. So let me see it. So from 0.2, if it is 10 seconds, around 10, more than 10 cycles will, around 10 cycles will come. Not 10 cycle, more than that will come. So it will be little confusing to watch it. If 0.2, around 10 cycles will come. It's 20 milliseconds now. So it is better to have 0.2, so that only 10 cycles will come and you can watch the waveform very clearly. So I'm just running this. The green button here is for running the option. So run this program. Once you run, you can see the output. So port 1 of thyristor 2 is not connected. It's given. Port 1 is this. I think the one. Usually that error will not come, even the ports you can have it open. I think some port is missing. So here some error it is giving. Usually this will not come. Let me just check it. What is the problem? First time I'm getting such, like, because this is a simple circuit, there should be no error in this. OD45 is there, so there is no problem. Variable step and adaptive. Some port, something is missing somewhere. So now it ran that it was just giving initially structure with time error was there, but that should not come. Even here the waveforms are not clear. Some problem has occurred. 1 second, let me see. It was continuous. 230, 50 hertz. So this is also correct. And pulse generated is 20 milliseconds. 1, 2, 3, 20 milliseconds. Here it is 1, 2, 3, 2.5 milliseconds. Okay, so in this case, 1, 2, 3, 20, and here it is 1, 2, 3, 2.5 milliseconds. So this values are correct. Some other error is there. Like, I think I opened one problem from internet now just to show you. So That model also, UPFC model also, I opened it before. So some problems there. I think here the AC supply itself 230 volts. There itself the problem is there. You are not getting pure AC. Okay, did I change the decimation to 10 or something? Yeah. So that's the thing. That's what I was just wondering, because this problem, I changed the decimation. In the sense, every 10 samples, it is taking a sample. That's why. So here you can just go and change the decimation to 1. Okay, so 5. So might be 5 or 3 or something you give, it will give more accurate. So that's why I said whenever you want to simulate some AC waveform, it is better you don't go for 10 here. That is a case when it is, as I told you, a solar application where a long data, the temperature or something, radiation is not varying. In such places, you can go for this. And here, once again, I'll just run and show you. So this is now a little more clear, okay? And if I want, I can just show you. Here 10 cycles are coming. In 5 cycles, it will be a little more clear. So here you can see this is the AC input 230 volts what we gave, and in that you can see the voltage across the load. So this negative region is because of the inductor. Okay, the inductor, at this point the thyristor get commutated, but thyristor will still conduct. That is because there is an inductor in the circuit. We have put an RL circuit. Okay, across the RL, if you put a freewheeling diode, what will happen? This portion will also get cut. Or if you put a pure resistance, this portion will get cut. Or now if you add an RLE, what will happen? This point and 50 volts, say if I put a 50 volt supply here, then that shift will be seen here. So all these things you can just try. And here the current, you can see the current is becoming discontinuous. If my load is a motor, the current will become continuous. And here, one more thing what you can do is, you can just go and change the style and the look of this. You can just change the look, like say if I want a red color thing, and 2, thickness is 2, property apply, okay. Okay, so here again this background also you can change the background color to white. So this overall it looks like this. And this same thing you can make it little more better in case of if you take these data to Workspace. In Workspace, the plotting is still more clear, where you can do more changes, like you can give the labeling and all those things more accurately in case of when you take the data to Workspace. That also I'll show you later how to do it. So this is the way you get the waveform. Now I'll just tell you some simple concepts like making a subsystem and masking a subsystem. So how to create a subsystem? Just click on this window and choose all these elements which you want to put it in the subsystem. So for example, I want to put I want to make a rectifier. Okay, in that case, I don't want this source and this voltage source to come in that. Okay, I put this outside and just selecting only this portion. And this, let this load also come. Full thing I've just selected, and this I'm just right click. You will get an option called create subsystem. Just create it. So automatically you can see here this subsystem is created. Okay, so in that case I went and removed that M terminal like small node there. If that node was not removed, you will get it here as an open node. So that's why I told you if you want, you can remove it. Okay, so now you can see this voltage, it is going from here to here and such a long line. If you want to cut short this line, what you can do is remove this line, and to pass the data you can have go to blocks. So go to, if you give, so this is the go to block, you can just connect it here automatically. And here if you bring the cursor here, you will get a small blue color thing projecting out like this. Okay, just drag this out, you will get the from block. So where you want to go and connect, you just connect the from. Okay, and this is A and this is also. So you can just go and see the label here. So if you click here, it automatically goes. And here also you can just go and click it automatically. So these both are A. So if you click, once you run this, you can see the waveform there. You can see the AC waveform there. The same way, now we have made the subsystem, just double click on the subsystem, this will open. And if I want to take these parameters also output, like in the output, you can do it. So let me take the pulse generator, 2 pulse outside. So I'm just deleting these 2 and putting go to blocks there. So I'm just putting the go to block. Okay. So here already the label was A, so I have to put some other variable. Let me give it as B and connect it here. Okay, I'm just connecting it in this. Similarly, I want one more block of this, so I'm taking it. So this B, let me keep it as C. So here one thing what you have to remember is, in the previous case, the visibility was local. When it is local, it will go from in the same window. Okay, so now we are in some other window like subsystem, and our main window is nothing but this window. So if you go like this, this is the main window. Okay, so what will happen is, if it is local, our main window will not be able to get that data. As in C also, whenever we declare a variable and we are going to use that variable in some other function, what we do, we declare it as a global variable. Is it? Same way you have to do it here. You have to go inside this and declare this variable as, I can just show you, say this I'll declare as global and let one be. So ye jo global hai, it will go from one window to the other, like it may go throughout the thing, it is visible, this variable is visible. But the other variable I have kept it as local, so let us see whether both the data are going inside or not. Okay, so similarly you have to come and connect here. So we want the go to from block, from block we are just connecting. We require one more from block. Let me keep this as B and apply. Okay, and we want one more, so let that be C. Okay, so when I put apply, that link will come here. See, that link is coming because it is globally declared. It will identify it. Okay, so but in this case, when you apply also, that will not come, the link will not come, because this system couldn't identify where is this B variable. Okay, so that is the thing. So you can just connect and also see here, connected, this is also connected. You can just take it near it and you can just run the program and see. Okay, you just run this program and see. You will not get that B data. See, B pulse is not there. Okay, that the reason why B pulse is not there is, here this B was not kept as global. So here, whenever you're using this go to block inside a subsystem, you have to declare that as global. Okay, so now we have made a subsystem and you can see it. But next concept is how to mask a subsystem. Okay, so next is how to mask a subsystem. So for masking a subsystem, what you have to do is, when you double click this, this window is opening. I don't want this window to open. Okay, when I double click this, this window is opening. I don't want this window to open. When I double click this, this window is opening. And it is asking me what is the voltage, what is the frequency. So I want such a window here. When I double click this, one window should open and tell me, ask me what changes you want to do to the system. So here, what is the parameter which is changing always? Firing angle, is it? Now it is 45. You can make it 90 degrees, 180 degrees. So in the morning lecture also, I told you when the angle is changed, how the waveform changes. So let me change this variable, that is my firing angle. So in this case, let me put here a variable A. So let me have a variable A, apply, okay. Similarly for this, let me give some other variable name and let me keep this variable name as B. Okay, I have just kept some variable name A and B here. Okay, so now again I'm going back. Here also the problem is the system doesn't know what is A and B. When I click, this window is opening. I have to mask this, and so that when I click this, that window should open and ask me what is A and B. For that, what I have to do, just right click on this, go to mask, create mask. So one window will open, and here we have to go and enter the parameters A and B. For that, how this window should look, what should be written over this or this, because now I have made my own rectifier. So I can have my own picture, or I can have a rectifier picture there. So in order to do that, here number of commands are there. The latest version, this is not available. You should know what command to write, but in the till 15b, this is available. So for example, I want here a like transfer function like this. So what I can do is say a transfer function like this will come here. So I click this and apply. I can see the transfer function is coming. So if it is a rectifier, you can just go and write and see. Say it will give text also. Say at 5,10 I'm writing Reena, or I can write rectifier. So rectifier will come like this. It will come here rectifier. You can just see here. Here as Reena it's written here. You can write your rectifier also. So if I want an image, say I want to put an image of a rectifier. See here an aeroplane image is there. Similarly, if you want some other image to be put here, you can just write the command here. This is a b747.jpg image already available in the system. So you can just put that image also. Okay, or here one MATLAB Simulink team is there. Simulink team. So you can just go apply. So Simulink team picture will come. So whichever you want, you can just go and apply. So this, you have to just search in your system where this picture is there. B747 picture. So it will be usually in your C drive. In C drive, your program files will be there. Inside your program file, there is something called MATLAB. So go inside MATLAB. You will get a folder of toolbox. Inside toolbox, again a Simulink toolbox will be there. Inside Simulink, again one more Simulink is there. So if you go into that location, you will get this image. So if you want, I can show you. Here you go to C drive. C drive, you have the program files. In program files, you will have MATLAB. In MATLAB, say this is 13 version. I have put my 16 in some other, 15 in some other location. So you went to MATLAB, say MATLAB. So in MATLAB, you have something called not Simulink. First, you have to go to Toolbox. Okay, so go to Toolbox. Inside Toolbox, again go to Simulink. Simulink is there. Inside Simulink, one more Simulink is there. So in this location, go and search that b747.jpg is there. In same location, whichever image you take it from Google or your own image also, see that the pixel is not very big. Then you can put it in this location. And then after that, you can call it here. Image within single quotes .jpg, you can call it here. PNG or JPG, both the formats are acceptable. Okay. PNG is also accepted and JPG. Okay, so both the formats are accepted here. Okay, so once you do this, once you do okay and you come out, sometimes the picture will not be seen when you're doing it for first time. Okay, because it's your new image you have put. So many times when you install a software also, what we do, we switch off the system and turn it on. So first time when you put an image, sometimes it may give you a question mark here saying that that image is not got. You couldn't get it. So what you have to do, you fully turn off your system and again reboot it, you restart it, automatically that image will come. Okay, so first time when somebody is trying a new image, don't get worried why it is not coming. That the reason is that image will not come until you don't turn it on and turn it off. This image, these images, many times it is already there and many times I've opened it. So that's why directly it is coming. Next, we are not worried about all those images. We have put two variables, A and B. We want that. So I'm putting an editor here. You can even put checkbox, pop pins, radio buttons, anything. I'm putting two editors. One is my first firing angle, and let me keep that parameter as A. So what parameter? I've kept the same parameter. You have to keep it in this parameter name. So here firing angle, let me keep it as A or A1 or anything. Then next is firing angle B. Okay, so like here the parameter is very important. What name you have kept there, same name should be here also. Okay, so I've given these things. Then initialization, in case say if it is a capacitor value or something, if you want to initialize the initial value, you can write it. Say A and B, two variables have come here, you can write it here. Next is documentation. Documentation, if you want, say this mask type, you want to keep it as some rectifier. So you can keep the rectifier name. You want to give some description. This is my model or anything. anything you want to write, this you can write it. And help, you want to give some internet link, you can give it. Apply. Okay, apply and okay. So now you go and double click, this window will open. Now that one, the circuit inside is not opening. Similarly, say when I click on this, the window is opening, same way this is also opening. This circuit is not opening. So here I have to give, say in case if it is 90 degrees. 90 degrees is 5 milliseconds. So how will I give? 0.005. And similarly, what will be for the other case, second two thyristors, it will be 15 milliseconds. So 10 plus 5. So 0.015. 15 millisecond, apply and okay. Okay, and now you just run this and see. So you can see here, this portion as, like say here, from here it is 90 degrees now. From here around 90 degrees it is fired here. Okay, so this, and here current is also more discontinuous. You can see here, current has become more discontinuous. And if the inductor value is more, what will happen? You will see a negative portion more. Here the inductance value is also less. In case the inductance value is more, you can see more negative. In the sense, it is, voltage is becoming more negative. Here the inductance value is less, that's why you can just try all those options here. Okay, one more concept is how to add coding into this. So you have a program for eliminating the harmonics in the system. Okay, so for example, here you can just go and see the harmonics also. You go to the tools. So I think now we didn't put the scope structure with time. So first of all, you have to add this history, save data to, okay, it was array. I am just putting it as structure with time, apply, okay. And I have to run this program. Okay, I've run this program. So now you can go to this Power GUI block, go to tools and go to FFT analysis. So this is the AC waveform you are getting. Okay, so 60 Hertz is given. Let me keep it as 50. Okay, so now you can see this is one cycle. So in this, for one cycle, if you see this THD, it will be almost 0%. Is it? Because it's a pure sine wave. Okay, so let me see the THD display. It's 0.77. Like slight changes there. You can change the time from like 0.05 and just see this cycle. So it is around 0.77%. Some small harmonics is there in the system that you can see it here. It is 230.3 volts. That is because of some switching or like some load or something with this THD is coming. So similarly, the other analysis can also be done. For that, what you have to do, you have to go to the scope, go to this history. In this, you go and save the data to Workspace, and format, you have to take it as structure with time. So this is very important. Only then, if you do this only, so you can see here, scope data, structure with time, and save data to Workspace. If you don't do this, then there is no possibility. Okay, so here next we are going to see how to add some like coding into this, how to add coding. For that, you can just go to, say here, libraries here. If you want, you can just go and search also. In library, Simulink, you go to Simulink, so you have something called user-defined function. You have something called user-defined function. So in this user-defined function, you have S functions, you have MATLAB functions and all these things. This MATLAB function can be used for such purpose, like for writing coding. Even S function is there. In S function, if you see, when you have a program in C or Fortran or something, you can use this S function. Otherwise, you can just use this MATLAB function directly. Okay, so in MATLAB function, just double click on this, a window will open like this. And here, this is the place where you go and write the coding. So here I had only one input. So in case, take a system, say you have a PV system. There you have taken the PV voltage and current and you want to do the MPPT or something. In such cases, you require two inputs. So let me keep one input as U1 and the other input as U2. Okay, and say output. I have two outputs. Just think my one is my duty cycle to one thyristor and the other one is the duty cycle to the other thyristor, something like that. So I'll have two outputs, say Y1 and Y2 are my two outputs. Then I have to define my system. So here I'm not clearly defining it, but simply I'll just show you my U1 is this and my Y2. Y2 is nothing but say U2 multiplied by some 1000. Let me give it as U2 multiplied by 1000, 10,000 or 1000. This is the value. Okay. Y1 is my U1 itself. So I'm just doing this. And I have to just run this model. So when I run this model, so some error came, but it has already run the model, and you can see here, these are the two inputs what we gave, and you can see the Simulink model. So now I have to give two inputs to it. One I'll give the voltage and one is current. So you can see here the voltage and current is coming here. Let me give the voltage and one I'm just giving the current. Okay, and this output I can see in the scope or any location. Or if you want to make a closed loop system and if there's some duty cycle or something, you can connect it to some motor. Or sorry, if you can connect it to the system wherever you want to connect it, or you want to fire it, you can just take the two firing and give it. Here I'm using a scope with two inputs. Okay, I'm just connecting this and this node also. So now I have to just run this. There is some error because when I started itself, there was some problem. But generally it will run, it will not give you an error. But here I think some problem, like when I started itself, MATLAB, there was some problem with MATLAB. Okay, so that's the reason. But otherwise, when you connect U1 and U2 and UV, you can see the waveform here. Okay, so this is a thing where you will get the output. So here, whenever you write a coding or something, you want to do a MPPT algorithm and you want to just implement it for maximum power tracking of a PV array or something, you can just write the algorithm inside this. Here, you just go and write the whole algorithm. Then automatically, you will get it. You will see the output there. You can try it in the lab, you will get it, but actually some problem had occurred in my system. That's the reason why you are not getting the output here. So this is how you will be doing. So now the same output, if I just want to take it to the workspace and plot graphs there, that can also be done. So in order to do that, two workspace block is there. Two workspace. Okay. So two workspace. 1 second, just let me see this whether I put this. That function was correct. I think some other problem is there. So two workspace. So if I want to take this data, I just imagine I want to take voltage and current, both the data to the workspace. I can just put a mux here. Okay, I'm just putting a mux. And these are the things like time series. This time series, I can make it a structure with time. Okay, and sampling is given here. Okay, so here if you see in each case, here it is given sample time -1 for inherent, -1. In some places you see sample time as you will be giving some value like 0.2 or something. In some place it is -1. Okay, so what is -1? -1 means it will take the sample rate of the previous block to which it is connected. Okay, if you give some positive value, it will just take that positive. Say if you give the sampling time as 0.2, it will sample at every 0.2 seconds. When it is -1, it means that it is taking the sample rate of the previous block to which it is connected. Okay, so these are some of the common things. Here there is no sample rate. So this is the thing. So in some block, I think it's in constant blocks. Yeah, I think some places it will be 1 also. When you have a constant block, the sampling rate is infinite. Sorry, that's what I was just saying. See, the sample time here is infinite. You're sampling it at infinite. In this case, you're sampling it at -1. Okay, in some cases, when you want to add a sample, say here you're adding, you will be telling sample like this. So what does it mean is, if it is -1, it means that take the sample time of the previous block to which it is connected. So here this is connected to this mux. So mux, what is the sample rate? Same sample rate, this will also take it. In case of constant, so in case of constant, it is infinite. It means that for infinite time, the sampling rate is like the same. In the sense, you don't sample it because if the value is constant, infinite time, the value is not going to change. So for infinite time, you take the value as 1 itself. So here it will not do more number of samples. It will not do any sampling. Can you understand? What is the sample time? Many places you would have seen infinite. If you put infinite, what is the value of this block? What if you put 10 here, that 10 will be the value till infinity. Okay, and in case here it is -1, it means what value the previous block has, that it will take. So now let me just run this. There is some error or something coming. So here the scope data is here. Okay, to Workspace Simscape data. I think some problem has occurred to my MATLAB. Those values are not coming. Okay, one problem is the current directory what I have kept is bin, so it will not allow anything to write there. So let me change the directory and see. This problem doesn't occur. I am not sure why. What problem had today? What was the problem? So now it has run the program. So let me see sim out is here. Okay, so sometimes you just see the error and you can correct it also. It will take little, like we have to put a new error, you have to sit and see. And if there is some big problem, what you can do is all these errors, already the solution are there in MATLAB file exchange, or some people would have some like question answer sessions will be there. Okay, so you can just go and see there what error they have got and how they have rectified. So that's not a big issue. So sim out you go. So this is the data in sim out. Okay, you can see all the data here. So again, go to signals. So you can see here values, go to values. So these are the values of voltage and current, which we plotted there in scope itself. If you want to take this data somewhere, say you want to train a neural network where you have the voltage and current of a PV array. So this data, you can take it to your Excel. Okay, and do it. So if you want to plot it here also you can go plot, do plot. So automatically you will get this value. Okay, so here you have all the flexibility to change it. Say I want to edit it. Go to figure properties, click on this. The figure properties will open. So here again you have the option. Here you have the option. Say you just click on this and you can just go and change the thickness of it. Okay, you want to have grid lines, just add the grid lines. You want legends, you show legends, it will give the legends. So if there are legends also, you can just go and change. Like one is your voltage. So voltage in volts, you can just go and change voltage in volts and all these things you want, right? Here also, if you want, you can just go and change the color to white. The background was not proper. These grid lines also, if you go to more properties, you can make dotted lines. All these properties are available, color and everything you can change for the grid lines also. Here you can go and change the font size of your icons and even make it bold. Okay, and here if you click on this axis, you get this x-axis, y-axis. So if x-axis you want to label, it is time in seconds. Actually, it is not time now, it is the number of samples. If you want to time, what you have to do is you have to go and plot it with respect to T out and this one. So that can also be done. So this is the thing. Y-axis, if you want, you can just go and write that is voltage in volts. So all these things are possible here, and which will make your presentation good, and you can present these articles in like paper or somewhere you want to take it, you can just take it and present it. Okay. And now say here, if your scale is, see, current scale is very small, but the voltage scale is very big. So if you want, you can just go and change that also. Here, say for example, I have my time. This is my time. So what is my time? Sim out dot time. So let me keep t is equal to sim out dot time. So this value came, my time value came here. Okay, sim out t, it is in t. Next, I just want this sim out signals dot values. So you can see the previous command. Previous command is plot sim out dot signals dot values. Okay, so here also you can just go and see if I want to plot this. So the thing is sim out dot signals dot value colon comma 2 is the name for that. This is the name. Okay, so and the other one, it is voltage. I've just changed the name as voltage. Okay, this one is the name voltage, and another one is sim out dot signals dot values colon 2. Okay, so when you want to plot it there, you have to just give the name properly. Okay, so here plot, you can give t, comma, this whole thing, sim out dot signal dot value dot colon. So if you give plot y. So plot y, you can see, I think you can see here. Centers couldn't see it. Anyway, plot y t comma sim out dot signals dot values colon this. And second one was I'm just deleting because the last case, this was the last one. I'm just deleting it. I'm drawing a simple thing. So t dot this. Let me keep this one. First colon. Similarly, I just want t comma the second one. Okay, what I did is plot y, that is a command, t comma sim out dot signal dot value colon 1 comma t comma sim out dot signal dot value 2. Okay, so just let me try this. So here you can see the graph how one of the x-axis is here, y-axis is here, and y2, one of the other axis here. So the current scale was very small, is it? I couldn't see that. Now the current scale has become big. Okay, so you can do, like when you bring the data, with that data you can play there, you can just do whatever operations you want to do. This is very helpful when you're presenting a paper and one of the parameters is very small, the current is very, so here you can see this axis is 0 to 1, sorry, 0 to 4. Okay, that red one is in 0 to 4 axis. So accordingly it is, so you can just, I'll just show you this axis. This is the red one and whose axis is y to this side. And the voltage axis is this. So now both the graphs are big and you can see the small changes in current also. Say there is a small notch here in the current. So all these things can be clearly visible. Okay, so this Simulink is a very good environment for drawing that too, mainly power system, power electronics applications. All these things are that can be easily done in this. Even load flow analysis for power system, when you go for a power system application, the load flow analysis are also available inside this Power GUI. That ma'am will be showing you tomorrow. She will take some bus system and she will just put different facts and she'll show the load flow analysis also. So she'll be using the blocks in power system and she'll be teaching you. So mainly when she'll be taking the SUVs and StatComs and all, sorry, SVCs and StatComs from the library. So in the library also all these facts elements and distributed generations are available. So one thing is you have to just, yeah, everything is already available in the library. You have to just go drag it and put it here. Okay, the PV I already told you, PV is not available. The older till 2015 it is not available. 2016 the PV is also available. It is available in the demos. You can just go to the demos and look for it. So here also I'll just show you where to go for the demos. So go to home. This is the main window. In that, here you have an help. An icon for help. Just click on this icon for help and here you have something called the examples or documentation. You can even go to the documentation. So all the toolboxes are available. So whichever toolboxes are available, all these documentation is done here. Say for example, Sim Power System. So if you go to Sim Power System, it is here. Just click on the Sim Power System. You will have getting started with Sim Power System. Number of modules are already available. You can just go Power System product description and acknowledgement, everything. Tutorials are also given. Building a how to build overview of this, and all these things are explained step by step. So you can, from this you can, and all these models are also available here. So if you want to open a particular model, so you can just go for, this is specialized technologies, transformers, power electronic modules are available, power electronics, inverters, converters, PWM, and machine models are available. Okay, and power, this is power utility, AC, DC network models are available. You have the 5 bus system, load flow tool, power geo, and all these things. So once you go into it, that description is also given down. Okay, this is a 5-bus network, and load flow tool is also used in this. Just click on this power, open this example. So automatically this example will open. Okay, and thus you can just go and run this program. So this is a 5-bus system which is already there. Okay, initializing a 5-bus with load flow, power geo is given here. And the scope is given here. You can just go double click on it and you can see all the values in the scope. Okay, so this is the waveform. When you read the when you read the article, you will understand what is the waveform and all those things. So all the examples are already available. So now a 5-bus system already you have. Now you want to connect a fax. You want to introduce some fault someplace. See, here also 3-phase fault is introduced. So that only you saw now. I think at this instant a 3-phase fault was introduced. That's why the system became unstable and that it is stabilizing. So you want to stabilize the system, you want to add a fax device or anything, you can do it. This is a wind farm. So you can see here 9 megawatt wind farm is this. So if you have a wind farm or a PV and all these things, you can just directly connect these models which are existing and then modify your system. Okay, so load flow analysis, these are the load flow blocks which are available for load flow buses that ma'am will tell you in detail tomorrow. Okay, so here you can go to the demos and learn. You can go to the demos, you can read the description, what they have given, at what time they have given the fault and how to run it and what to watch, everything they have explained here, simulations and the descriptions, you can just go and see. Okay, so this is about today's lecture. You have to just know the basic, because whenever there is a go-to block or when there is a subsystem or anything, you should know what is the block actually. Without knowing, say here itself, if you see, there are many things. So you have to know. So when I double click this is, so it is a masked window. It is asking me some machine parameters and all these things. So you have to know this. That is the main thing. Okay, so here you can see when they have put it in the phasor mode and they are doing this. So all these things are, you have to be clear, like how they are doing it, what is the ODE. ODE is the ordinary differential equation at which they are running this program. So here you can see the ODE 23. So if you go to simulation, model configuration parameter, mostly whenever you are running a simulation, you have to keep it as variable step. Okay, it will be, step will be varying. But if it is a fixed step, it is for a hardware. Whenever you're connecting a hardware, your system will never come back. It was always running in the forward direction. Okay, so if you put it in a fixed step, it will never come back and see whether there is a change or not. But variable step will do that, because that is only for simulation, continuous. I can just show you an example. And ODE is the different ordinary differential equations. This is second order and third order. You have 45, fourth order, fifth order. This is the common thing which is used here. So here what will happen, whenever you will do a model, at the back end, one ordinary differential equation is there, which will solve these and give you the answer. Okay, you have put the model, but from where are you getting the results? It is by solving these models. And this variable step and fixed step, I'll just show you now. Let me open a model. So let me keep a step input. So let me have a step input. I'm putting a gain block. Just multiplying by some 2 or something. Simple to just see this. And I am just putting a scope, okay, to see the waveform. So here, now first of all, that this parameter was in variable step. Let me keep it in variable step and run this. Okay, so here it's a step input. Okay, after, like, final value will be 0. Initially it will be 0 and finally it will become 1. So just I'm running this. And you can see the output. After 1 second, I've just changed from 0 to 1 and the constant is 1. So you can just see here how many samples it has created. It will be 51 samples. Or say here T out, it is 53 samples. It has created 53 samples. Okay, here it has created 53 samples. Why 53 samples? In the place of that 1, when it was 1, what happened? Every time it will create only 51 samples. Okay, if it is a constant, if you have connected a constant, it would have given only 51 samples. Because it's 0 to 0.1 or 10. Here I have kept 10 seconds. 0 to 10. So it is 10 minus 0 divided by 50. Always it is 50 samples in one simulation. MATLAB default is that. So in this case, what happened? There is a change in 1. In 1 second, there is a change in your unit. So here you can see in this 1, when it was 1 second, 0.8 ke baad jab 1 ho gaya, 1, 1 and 1. In the sense, first there was a change in 1 second, the magnitude became 1 in 1 second, and again it is rechecking, it is going back and checking. So that's why there is 3 ones. In 1 second, there was a change, so it went and repeatedly saw what is the value. Same thing, let me keep it as fixed step. So let me change this as fixed step. If this time, if you see it, there will be only 51 samples and that 1 will not be repeated. And here in this case, fixed step, you can see in 1 it is changing, but it is never going back and seeing whether the answer is correct or not. So this is what's happened in real time. Real time, our system, when our clock is running forward, our system will not go back and see whether there is change. At that instant, what value it is getting, it will just give you as output. Okay, so whenever you run a real-time system, hardware, when you connect, you can never give it as like variable step. You have to give it as fixed step, because variables. So here you can see the value, say 51. Abhi aapka 51 ho gaya. Pehle it was. So and here you can see in only one time it is there. It is not 3 times repeated. Okay, even if you give a constant in variable steps, say now I gave a change there, but let me give a constant here. And I'm changing this. So in this case, when it's a constant, it is not going to change the value. Okay, in this case, it is not going to change my value. So here you can see 51 only. Sorry, this was fixed step. Sorry, it was fixed step. I'll just change it to variable step. In variable step also, this shouldn't give me more samples. It should be giving me, say, 51 only. Okay, it is only 51 in variable step also. So variable step, whenever there is a change, say firing pulse you are giving, and there is a change in the firing pulse, is it? So at that time, what variable step does, it goes back and check whether that's perfectly done or not. Okay, there is a perfect change. So fixed step will not do it. So that is about the parameter setting. You have to know. So that is one thing, is you will be given stop time here. This is variable type and fixed step. Fixed step mainly you go for hardware models. Then OD45 is there. That is ordinary differential equation. Relative tolerance, at what error you are accepting, that will come here. And these are some of the things. And here, if you see code generation, you go build here. This is for hardware. So you generate the code in C and you can flash it into any hardware you want to connect it. So this is about MATLAB basics. I think now all of you are clear with the MATLAB basics. So if you have any doubts, you can ask. You can just go and work on it so you will know it. Yeah, practice sessions. Okay. Yeah, the Simulink is a very good window. Like, it's a graphical thing. You have to just pick and drop and connect it. Yeah. Yeah, you can do image processing. You can do like fuzzy logic, neural network. All these blocks can be connected to this. You can have a real-time system. You can acquire data into it and you can do it. So a lot of things are. Okay. This is also simple. Once you go, and I told you, go to the help. If you go to the demos and helps, you will get lot of examples and you can work on this. Okay, so now this lecture is also available online. So whenever you want to go and see this, yeah, you can just go. Otherwise, you can just go and search for Simulink MATLAB solid state control of drives. Shimmi ऐसे सर्च किया तो भी आपका like starting से और भी parameters मैंने, because according to time we just cut short it. There many other examples also I have given, so you can just go through that also. Okay, MATLAB Simulink बोल के Shimmi सर्च किया तो आपका first जो वीडियो ओपन करता है, there also all these basics are there in a different. Yeah, you can just download, even the download the latest version. Okay, people may have it, you can get it from them and use it. Okay, so in the nodal centers, if you have any doubts, you can ask. This is the basic. Tomorrow ma'am will be teaching you the SVC StatCon, so that time directly she will be using the blocks. So you have to know how the subsystem is created and all those things that we discussed today, the same thing. And basically morning we discuss how to set the firing pulse or what is the logic behind it. So that is also discussed. So this the basic is over today, and from tomorrow we'll get into the lectures. They're like different in-depth lectures we'll go. So in the nodal centers, do you have any doubts?